Okay, so yesterday we talked about how to do a differential equation that is first order linear. So let me just show you kind of what you now should be able to solve. Okay, anything that's y prime plus garbage y equals garbage with no y. You should be able to solve any problem like this using the method I showed you yesterday. And it was all very clever. We multiplied by an integrating factor. Okay? All right. So the questions for today are going to look a little different, but we're going to turn them into problems like this and solve them. Okay? So let me show you an example of that. So the first problem I have for you is, let's say you're given y prime minus 1 over 2x y equals xy squared. And let's just say that x's are positive. You'll see why later. Let's say you're given that problem. This looks a lot like a fold EQ, first order linear differential equation. But something's not quite kosher here. Something's wrong with this picture.
There's a lot of names.
Yeah, it's supposed to be, if it's a first order linear, remember, it's supposed to look like y prime plus garbage y equals garbage no y's. But look at the right side. What do you notice? There's a y squared. So who invited this? Who invited the y squared? Evidently the x did. You know what? We can't have that y squared if we're going to use an integrating factor. This is not the right type of equation. So Bernoulli came up with an extremely clever way of getting rid of the y squared without corrupting the left side. It's pretty cool. No? Here's what he did. He said, let v equals y to the 1 minus n, where n is the exponent of the uninvited factor. Okay, now Bernoulli probably didn't say it quite that unprofessionally. Okay? But what he's saying is, whatever this guy, this uninvited guy's power is, that's n for this problem. So this is an n equals 2 Bernoulli problem. This is an n equals 2 Bernoulli problem. So for this problem, n is 2.
Some people have already graduated.
All right, so what is Bernoulli suggesting? We're going to replace, we're going to put in a v, and the v is always 1 minus n. This is Bernoulli's clever little thought. Let's see what happens when we do that. Okay, so for this problem, v is y to the 1 minus 2. In other words, what? V is 1 over y. Right. Or you could say y is 1 over v. Right. Okay, now this guy, you'll need it. Keep that handy. And let's find its derivative, too. What would y prime be? That would be the antiderivative. Negative 1 over v squared, right, times v prime. We're ddxing, so we cannot just do 1 over negative 1 over v squared. We need a chain rule here. Okay, armed with these two things, we can actually rewrite the original problem. And guess what? If we do that, it's a fold. It's very ingenious. Let's take a look back at the original problem. The original problem said y prime minus 1 over 2x y equals xy squared. Watch what happens when we write it with our newly found variables. Instead of y prime minus 1 over 2x y equals xy squared, we will substitute some things. Goodbye y prime. Hello, negative 1 over v squared v prime. Minus 1 over  goodbye y, hello 1 over v. And xy squared, goodbye y squared. How about 1 over v squared? Now we're going to multiply by v squared, or let's actually multiply by negative v squared everywhere. So I want this to be a 1. Remember, a fold always starts with a 1 right here. Multiply by negative v squared throughout the equation. And this is like magic. We get v prime plus 1 over 2x v equals negative x. That's magic. That's a fold. Blah prime plus garbage blah equals blah no garbage. Or garbage no blah. So that is a fold. And that's what we learned to solve yesterday. So Bernoulli converted a new problem into an old problem. Very clever. Okay, let's review. How do we solve this thing? Well, we multiply both sides by a special magic factor. And that special magic factor is, yes, it's going to be the antiderivative, e to the antiderivative. So you're going to multiply, it's always by e to the, and then what's the antiderivative of this? We usually call this little guy p of x. What's his antiderivative? ln, it's 1/2 ln x. Yeah, 1/2, because you're trying to integrate 1 over 2x. You can show your work if you want to. You don't have to do it in your head, right? I was doing it in my head yesterday, but we could definitely show some work there. And that's 1/2 ln x. So I'll just erase it for now, but 1/2 ln x. You don't need the absolute values on the x, because if you read the instructions of this problem, I said x was positive. And there's another way to write e to the 1/2 ln x. What's a cleaner way? E to the 1/2 L in x is e to the L in x to the half. How about just x to the half? If we're going to distribute something, we might as well clean it up first, right? Okay, so here's what we're going to be multiplying by. We're going to be multiplying by x to the half. That's our integrating factor. So this is now x to the 1/2 v prime plus 1 over 2 x equals, or sorry, times x to the half. Make sure you multiply each of these three terms. 1 over 2x to the half v, there we go, equals negative x to the 3/2. So I multiplied each of these by rad x. That became, rad x v prime. This becomes 1 over 2 rad x v, and then this is minus x to the 3/2. So why do we do this? Why do we multiply by the integrating factor? Because this now is, watch close, this is an f g prime plus f prime g. It's a perfect product rule. Look at that. Can you identify f and g for me? F is what? X to the half. And v, the g is what? V, right. So this is the derivative of x to the half v. And now the problem's in the bag. We are going to integrate both sides, and we have got it. Okay, so when you do integral on both sides, make sure you make this cool sound. And make sure you do it on the other side too. You can do a different sound if you like. It's pretty important. And yes, I do these things when I'm working alone. I certainly do. Okay, the left side cleans up. The integral of d anything is just that same anything. So this is just x to the half v. And the right side, we're adding a power and putting the reciprocal of the new power in front. So it's negative 2/5 x to the 5/2. And then, of course, a big fat plus c. We write them big and fat so we don't forget them next time. And now we solve for v. Divide by x to the half or multiply by x to the negative half, however you like to look at it. I think I'll write it like that. Okay, so I did it, right? I solved for v. Wasn't that the original plan? Look back at the original problem. Were we asked to solve for v? Yeah, we're trying to solve for y, but we're one step away. What was the original relationship between v and y? For this problem, remember v was y to the minus 1. Y to the minus 1, remember that? So let's change this left side to a y to the minus 1. And then that just means if we want y, we're going to reciprocate this whole thing. Okay, now if you look on Wolfram alpha, alpha can solve this Diffie cube perfectly every time, okay? So if you typed this original problem into Wolfram alpha, it would solve it for you. It knows how to do it Bernoulli. It's very cool. But it won't write the answer the same way as you did, probably. It'll probably multiply top and bottom by 5, maybe multiply top and bottom by radics to clean things up a little. Just be aware that your answer might be right, but look a little different. Don't forget that c, right? Because if you forget the c, then you're assuming that c equals 0 is the only solution, but there's actually an infinite number of solutions to a differential equation from all. Okay. So what's new about this problem is the part before this step. This is new. This is just yesterday. Okay? Oh, actually, technically, the new part started a little bit above here. The new part is right here, where this red line is. The new part is above this line, I mean. Okay, let's go and look at a second example. Okay, this time our function is, or our equation is, dy dx minus 1 over 2xy equals 1/2 ln x y to the minus 1. And this time, both x and y are positive. So first quadrant only. That's my prerogative. I wrote the problem, so I can make that up if I wish. Is it a fold? Why is it not a fold? That's right. So there's an uninvited something. It's right here. Who invited that thing? So Bernoulli said, no, I think 1/2 ln x invited it this time. So we're going to let v equal y to the 1 minus n. This is what Bernoulli said. You always use this same exact thing. But what's n for this problem? N is -1 for this problem. Very important that you identify n properly. Okay, so for this problem, we're going to be doing v is y to the 1 minus -1. So v is y squared. I'm telling you, if you get this part wrong, you're going to get the whole problem wrong after 10 minutes of wasting your time. So you've got to get the v and y thing figured out real early. And then go ahead and isolate y. So y is rad v. Now you can see why I wanted to stay in the first quadrant. I don't want the plus or minus in this at all. Okay, hang on to this. He's very important. And let's get his derivative while we're at it. So what's the derivative? 1/2 v to the minus 1/2 times v prime, right? We never want to forget that chain rule. Okay, rewriting the original problem. It's going to look like this now. So we scoot that over a little bit. Okay. So the original problem is now, instead of dy dx, we're going to put 1/2 v to the minus half v prime. Guess we don't really need parentheses there. And instead of minus 1 over 2xy, it's going to be minus 1 over 2x rad v. Or you could do v to the half. Maybe I'll stick with one notation. We'll do v to the half. And the right side, 1/2 ln x. It says y to the minus 1. So that would just be v to the minus half. Because remember, y is v to the half. Okay, you're one step away from a fold. So now you're going to multiply by whatever makes this a 1. Remember, we want 1 here. So for this problem, you're going to be multiplying both sides by 2v to the 1/2. Yeah. 2v to the half will do it. This is not an integrating factor. This is just getting it ready to look like a fold. Okay, so it looks like this now. V prime, that's exactly how a fold should start, minus, and I have to multiply along all three green arrows here. So if I multiply 2v to the half times 1 over 2x v to the half, I'm basically going to get 1 over xv. And then this right side is just simply ln x. If your fold doesn't look a lot nicer than your original, you probably did something wrong. Your fold should be independent variable derivative plus garbage independent variable equals garbage no independent variable. That's a fold. And now you're ready to do the integrating factor. So now we're going to multiply both sides. So this is yesterday's lesson now, from this point on. You're going to multiply both sides by e to the negative ln x, because 1 over x is antiderivative, or negative 1 over x is antiderivative is negative ln x. What's another way to write e to the negative ln x? X to the minus 1, yeah. So this is just x to the minus 1. In other words, this is just 1 over x. And if you multiply this in, you basically get x to the minus 1 v prime minus x to the minus 2 v equals ln x over x. I thought it might be easier to use power notation for the left side so you could clearly see the product rule there. And this is just the derivative of x to the minus 1v. Almost there. Now we integrate both sides. We learned our lesson last time. We have to make that sound. So we go. And the left side is just going to become x to the minus 1v. The right side, we're going to have to think about this. It's the integral of ln x over x dx. This integral we're going to have to play around with a little bit. This is a little bit harder now. I think it's just ln squared. Let me show you why. If you let u equal ln x, du is 1 over x dx. So we just converted this integral to the integral of u du, basically, which is just 1/2 u squared plus c. Okay, so the left side is x to the minus 1v. The right side is 1/2 ln x quantity squared plus c. Now we're going to multiply both sides by x. And that includes the c, by the way. cx. And remember, on this problem, v was y squared. Remember that? V was y squared. So now it's time to square root both sides to get our y. I already declared that y should be positive throughout this whole problem, so I don't want any plus or minuses there. And there you have it. Okay? So it's extremely powerful, and it's always a good thing when you learn that a new problem can be converted into an old one that you've seen before. That's always a healthy perspective. Sometimes we just need experts, professionals, to give us those clues. Bernoulli is to be credited for this one, I believe, although I wouldn't be surprised if someone else figured it out too. But it's a pretty clever substitution and allows us to solve these. Obviously, you guys can go on Wolfram Alpha and just type it in and see if you got it right? But my worksheet does have all the answers on there, so you don't have to even go online. So, the last problem I'm not going to finish, I don't think we need to, but I do think that you need to be careful when you try to identify your n at the beginning of a problem. So let me show you how example 3 starts, and we'll just stop when we get to the fold part. Here's the problem. It says y prime over y minus 1 equals e to the x, y to the negative 2/3, and y is greater than 0 like last time. There's something very deceptive about this problem. After doing a few of these, you're like, oh, I'm supposed to look for the uninvited term, and you circle this. Yeah, if you're thinking that n is equal to negative 2/3 on this problem, you're actually wrong about that. This is not an n equals negative 2/3 Bernoulli. Okay? And who knows what will happen if you pursue this as your n. This is totally wrong. The problem is the way the question was written, you were not ready to recognize what was uninvited here. Okay? When I was looking at those previous two problems and I said who invited that thing, the left sides were fold. And in this problem, the left side is not a fold style. It should look like y prime plus garbage y equals garbage y to the n. That's a Bernoulli. It's not what this problem looks like. So you need to do what, Hunter, you just said a second ago. What do we need to do? Yeah, we need to multiply by y first. Here, here, and here, so that we can properly identify who the imposter is. Okay? So it's y prime minus y equals e to the x times y to the 1/3. Now you can identify who was not invited. You need to look closely after you've got the left side organized. It's like a party, right? Someone might come who's crashing the party, but you don't know who it is because you don't have a roster. Okay? Roster? The list. The list. So, but if the left side is orderly and the right side appears awkward, maybe there's an uninvited term, right? So maybe you're like, who is the imposter? Who's the uninvited guest? Well, let's get things organized and then we can tell. That's exactly what's going on here. It's an n equals 1/3 Bernoulli problem, not an n equals negative 2/3 Bernoulli problem. So this really messes up students who aren't being careful. So this is an n equals 1/3 Bernoulli, ready, solve, you know. Okay, so there's my lesson. I don't know.